Alright, Assalamualaikum and very good afternoon. So today we are going to continue with our project. So it is project 2, dynamics analysis, and we're going to do a drop test. So you can go to your VLE and download this lab sheet and open it up. And go for the last pages. Last pages, we're going to do this one. This one. So this is about 20%. And let's look at the problem statement. So what are we doing today? We are designing packaging. We are doing packaging design packaging design of this CPU by using expanded polystyrene foam or EPS material. So we would like to test whether the packaging will protect our product, which is a CPU, from a 1 meter drop test. And you also need to minimize the volume of the polystyrene material which is used in your design in order to keep it economical. And you can determine what is the final carton box size. So EPS or expanded polystyrene, you can go to these links to read a bit about them. So typically package cushioning, this is the main usage for EPS. You want to avoid any sort of vibration and impact shock on your components inside. So these are the typical design. Normally they will use either end caps or corner blocks. These are the types of packaging that they will use. Okay, so let's take a look. Properties of expanded polystyrene, you can refer to the PDF here. You can double click and this will come out. EPS recycling, take a look at a bit, read a bit about this. You might come across this one when you are working. The physical properties of the EPS, it varies with the density change. So maybe we want to keep it at a high density. And the tensile strength is about 108 psi, or you got to convert this one. Read a bit about it. It is actually recyclable. EPS is actually recyclable. In terms of the materials, you have a printed circuit board inside your CPU. And then this is the material packaging foam, which is PS polystyrene foam. Young's modulus is about 3 megapascal. Yield stress changes. If you want to go in very detail, you can go make it very detailed. Yield stress changes with plastic strain. Material properties of aluminium, this you can use 1060 and your material database . Okay, so let's take a look at your design. In your design, you can put in one sensor. Under sensor, you can key in simulation data, workflow sensitive, and click the vertex on the motherboard. This will output the result when it is undergoing drop test. So we are going to drop test at a 45-degree angle . There's no need to drop test at a flat 0-degree angle. No, you just immediately choose 45-degree because this is the severe angle for it to drop. And then put all the information here. And then we will get the time history output on the sensor itself. We can find out what is the ARES, which is acceleration magnitude. Okay, so let's proceed. Let's download our drop test CPU CAD and then download the whole folder. Let's extract them. 7-zip extract to and then there is this component lah. Just click assembly file, which is this one. You're gonna get the whole thing. Currently the CPU is like this. Is there any planes that you can see created? You only have front, top and right plane only lah. So you only have these few planes that it's available. So you need to create a new plane lah to rotate it at 45-degree angle. I can hide it. So again, let's go to simulation. And new study. And then let's go to drop test and then click OK. And then we need to create one plane. In order to create the plane, I think I have to go to assembly and then reference geometry plane. I need some references lah. So I can choose this plane and this plane. I will automatically get a 45-degree angle. So this can be used lah for it to be dropped. Do you want to go in that way or do you want to flip? Can I flip it? Flip ah? I can flip it like that. Okay, so that's 45. So I can click OK. So I've got a drop plane lah. So later when we set it to be dropped, it will drop like that lah. Like that. So there is no need for you to rotate your component. You just have to rotate your plane lah. So let's set it up. Parts. I've got CPU, motherboard, and desktop CPU. Okay. So desktop CPU, I need to assign it as a material lah. CPU, this one, we consider it a very expensive CPU, which is made of aluminum. What do you call this? iMac. So desktop CPU, apply edit material, go to aluminum 1060 alloy. This one is okay. So click apply and close. The whole thing is aluminum alloy lah. And I've got a motherboard. So this motherboard, I need to create a new material. The material will be PCB. Right click, apply, edit material. I can go to custom material. There's one already created here. I can create a new one, new category. Board, maybe. Under that particular new category, I can right click and then create a new material, PCB. So this is my material, which is PCB, and I've got to change lah whatever that is required. Whatever value I don't know, I can remove. Thermal conductivity, I don't know. Do I know tensile strength? I don't know yet. I only need to key in materials, which is red color lah. Red color is crucial for your analysis. So let's take a look. PCB, the material is FR4. Young modulus is 22,000 MPa. Okay, let's go. Elastic modulus 22,000. E6. Poisson ratio is 0.28. 0.28. Mass density is 1850 lah. Mass density 1850. What is my tensile strength? Flexural strength. I only have flexural strength here, 345. I don't have tensile. No. Flexural is bending. It's not actually tensile strength. I don't have to put it. I don't have it. So I'm going to click apply. And I'm going to close. Now I can check back whether my materials are okay. This is CPCB. This is aluminum alloy. So I'm good lah. Only thing I need to do now is to put some sensors. How do I do that? Create sensor, simulation data, workflow sensitive. Okay, let's go. Simulation data, sensor. If I'm not mistaken, sensors are here under evaluate. Click on sensor. Change from mass property, change to simulation data. What are we looking at? We want to look at stress, or do we want to look at acceleration? Data quantity is workflow sensitive. Data quantity is workflow sensitive. Where is the location? The location is at the middle of the motherboard. Click OK. Do I have the sensors here? Okay, I've got it. Sensors are done. Should be fine. Let's try. So let's go to setup. Setup, define and edit. Drop height is 1000 millimeter from the lowest point lah. Drop height 1000 millimeter. Where is my gravity? Gravity is this plane. And it's going down like that. So that's good. My target is a rigid target. The floor is rigid. Normal to gravity. This is okay. Click on OK. And then let's mesh it properly. Create mesh. And go back to your simulation and... Oh, okay. Are we here yet? You're supposed to be able to run some studies here. Setup is okay already, right? Everything is good. Run this analysis lah. Mesh is also okay, right? Details 99%. Run the analysis. It's gonna take some time to solve it. How do you get the results? This one. Define time history plot. And then click the vertex that you have it. And then translational acceleration. Do you need the sensor to create this? Maybe not. Maybe yes. So this is done. It's a good idea to animate first and make sure everything is running okay. Is it properly being dropped at 45-degree angle? Okay, it's being dropped that way lah. Okay, so let's look at some acceleration. Right click on result, define time history plot. Result, define time history plot. We would like to check at time, okay, not stress, translational acceleration, A resolution, this is okay. Which node is it? That is not a good idea lah for you to look at every single node. That's not suitable lah. I cannot click predefined location here. Can I look at my sensor result option? Currently it's up about 310 microsecond. Yeah, predefined location. I can't click predefined location. I have result for all nodes. Maybe the sensor didn't go through. I don't have a proper. Normally sensors created will be here, under here. Workflow sensitive. Here is it. Update. Here is available. Let's try to look this one. Result, define time history plot. We don't want to look at translational acceleration. It's not a good idea. Unless you can really determine the node there. Can I click this one? I'm not, currently it's chosen as node 1. Where is it? Node 1, that's not true. I'm not sure where is node 1. Might as well show mesh. And then click this one. What node is this? Plot tool. Least selected node. Update. This is node 69. You can, one way to do it is like that, node 69. Right click, define time history plot. I gotta click node 69. Node 69 and then change back lah. Translational acceleration. Click on OK. So this is the acceleration on the board. The highest is about 3.610 to the power of 8 in millimeter per second lah. If I want to change all these values to other value, for example meter per second, I gotta change here lah. Edit document unit, custom, and then change length to meter. Meter, mass section unit, millimeter, change to meter. Click on OK. Has it been changed? No, I gotta do it again, I think. Response time, delete. Yes. Response to, delete. Yes. Result, define time history plot. Node 69. Time, change to translation, acceleration, x-axis, y-axis, no, x-axis should be time, y-axis should be translational acceleration. This is okay, time and acceleration. Click on OK. You can get it. Again, still in millimeter per second squared. So take a note on this value. Or you can also right click, edit definition. I think you can export this one. Can you export this one? Option file. Yeah, save as. Save as under CSV, which is comma separated value. Alright, so this is without any enclosure, without any packaging. So next, we are going to do it again. However, currently with packaging lah. So how do you do this? You have to go to assembly, and then you need to create enclosure lah for it. So roughly, let's take a look at the size of this thing. It's a good idea to get some rough sizing. Evaluate, measure this distance, 0.5. Oh, everything's in meter now. It's a bad idea. Change back to millimeter. Measure 150. This is measure 324. So 150. The width is 324. Or in reality, maybe measure this point to this point. 250 lah. 250, and the height is here to here. Measure. Height is same 250 also. 350. So you can create file a new part. And go to the front plane, sketch a rectangle. Currently, the height is 350, right? So 350, you gotta add some thickness lah. Maybe 5 centimeter on each side. So add another 100. 450. This width also same lah, 450. And then we can extrude on the features, extrude boss. The width is 150, 150. So you gotta add 100 more thickness. So it's like that lah. So this is the polystyrene foam. File, save as, desktop, FOAM, foam, save. Now if you go back to your assembly, I've got an assembly here. I have to assembly, insert component, click foam. So this is the foam that will encapsulate your product. So you got to click these icons. Click Y, maybe like that, so it aligns properly. Okay, so some sort of like that lah. So now you have to put it in between lah. How do you put things in between? Click mate, advance, width. So it is between this and this, and also between this and this. So it will move accordingly. So click OK. And then another width between this, and also between this and this. Again, it has changed accordingly. Finally, one more width between, I guess I should take it out a bit. Okay. Bring it slightly closer. Mate, advance width between here and here to here and here. Click on OK. So the whole thing has been encapsulated lah. If you really want to see the inside, you gotta right click and then click on transparency. Change transparency. You can see the whole CPU has been encapsulated properly. So this encapsulation is actually a solid thing. So you have to remove certain things lah. How do we do that? We have to go to assembly, click on a component, click component. Right, because currently this foam is actually solid solid like this. It has to have some hollow section inside. So on the CPU, you have to click a component, which is the foam. And now I can edit component. Okay, if I don't click any component, I cannot edit that component lah. If I click this foam, and then I hit edit component, now I can do modification process lah. And the process that I want to do is something called insert features. I guess this one, cavity. Click cavity. Design component. Is it cavity? Let me check it out. Features cavity, design component, click the component. And then we can do it already lah. This one, I have to click desktop CPU lah. Desktop CPU. Desktop CPU. Can I click one more? CPU motherboard. I think so. 2 items I need to hollow it up and then click on OK. And what's happened already to my foam? In order to take a look at it, I have to go to, and now I exit this one, exit edit component. In order to take a look at it, I have to go to foam here. And then I change my display to hidden lines. So if I click on hidden lines, I can see the internal part has been hollowed out. If I really want to see inside, I can click this one. Section view, drag inside. This actually has been hollowed out. Can change the plane. Click OK. Certain things has been hollowed out lah. So now there is this thing that you need to do because everything has been hollowed out like that. So you need to decide lah what kind of packaging design you want to use. Maybe you want to use end cap, Or do you want to use corner blocks? Maybe top and bottom half. So maybe I'm going to go with the top and bottom half. So I am now at individual component, foam, not desktop CPU assembly. This is assembly. This is foam. So currently my foam is like this. I want to do some modification. So like if I change this one to display like this, right click, sketch, control 8. So maybe I want to remove certain things. Top and bottom, right? Smart dimension here to here is about 150. Here to here is about 150. Too much, eh? Maybe yes, maybe no. 120. You decide on your own, okay? 120. Click OK and exit sketch. And then I can extrude cut lah. Extrude cut. Through all. Click OK. Okay, so I've got top and bottom part of it lah. However, I gotta do some machining a bit lah, this one. This one needs to be hollowed out more. If you look at it properly. I suppose I gotta click this one and then sketch, control 8. How do I hollow it out? Where is the reference? Convert entities. You can use that one. 1, 2, 3, 4, 5. Okay, I've got an outline here. I think I just have to connect this line here to here. No, it's not yet been connected. Line from here to here. Click OK. Exit sketch. I can now extrude cut. Blind, right? The other way around. What was it? I think it's up until surface lah. Up until surface. Up to next also can. No. Up until surface. But what surface? This bottom surface lah. This one. The whole thing will be hollowed out. Okay, see? I've got the bottom and the top. So I've got two halves. If I go back to my desktop assembly, I'm gonna see. Yeah, I'm okay now. This is my polystyrene. So what do I do now? My foam I can change back lah, my transparency. I only need to go back to drop test. And then I gotta create another material lah. Right click, apply material. Solid body, top and bottom Apply edit material. This has to be a new material lah. Do I have foam here? I don't think so. Plastics. APS adakah? Polystyrene. PSHI. Can't be sure. Gotta key in on your own lah. Expanded polystyrene is EPS. I don't have it here. So you gotta create a new one lah. Create under custom lah. Under board. Right click. New material. The material is EPS. Apply. So EPS is here. Again, we follow the same drill lah. Remove all the unnecessary values. Elastic modulus. Shear modulus. So let's take a look at the material properties again. Expanded polystyrene, what is the density? Do I have it here under polystyrene? Packaging foam, okay, Young's modulus 3 megapascal, okay. 3E6, 3 megapascal. Poisson ratio is 0.00. I cannot key in 0.00. I gotta put in a value. Can I put 0? Maybe some problem if I put 0. Density is 100 kilogram per meter cube. Density is 100. Click apply, click close. And now I gotta mesh again, right click, create mesh. And then I gotta drop again lah, run this analysis again. So we gotta be able to compare previous and after. This one is the previous acceleration. What happens after you put polystyrene? Is it running right now? Yeah, it's running. Can I just... I gotta change back. Check back what is the node number. It might not be the same because I have all these extra nodes. Okay, you can forward a bit lah the video later. Takes a while to solve. Alright, so we're getting there. Let's check my mesh first. Probe. Can't. Okay, this is the point. Mesh node 69, still the same. So I can immediately show this one. Show. Is it here? Right click. Edit definition. Node 69. Click on OK. See? Maybe there are some improvement. 9810. 9830. Almost nothing. Millimeter per second. So there's a big difference between both. You get pretty high shock in the PCB once you drop it. But then again, we should animate first. Animate first, make sure is it really being dropped at 45-degree angle. Animate, play. Nothing's happening. Animate. It's creating some frames. Okay, it's being really dropped. And the foam is actually absorbing all the impact. So nothing is actually being transferred to your component inside. If you want to look at stress values and all that, you can do that. How do you do that? You can right click foam and then model, right? Go to model, foam, height component, go back to drop test, show back the stress, and then if you want to see it, you can click animate again. See that it's really being dropped, but barely anything happening. Right? There's no stress at all compared to the previous one. So this is how you do it. Alright, good luck.